And welcome back. As we go ahead and continue to dive into looking at C++, let's go ahead and take a moment to recap input-output and some of the things we're going to need to keep in mind when we are starting to work with some of our data types that we're going to use. So just a quick recap with cin and cout. Recall that we have used cin to get input from the user and cout to display output. However, we should be aware of data type conversions that may occur when working with variables because this could affect our expected outputs. Much like other programming languages, C++ uses both implicit and explicit conversion, or typecasting, to move across data types. So let's start first with implicit conversion. The type conversion that's done automatically by the compiler is implicit conversion. So if we look at this example, you'll see that the int is automatically converted to a double by the compiler before it is assigned to the variable. So here I have int num int is equal to 9, double num double, and we're going to go ahead and assign that to a double variable. And so num underscore double is equal to num underscore int. Notice there's no parentheses here or anything like that to indicate that we need to do a conversion. Instead, this is all handled automatically by the compiler. Now we, of course, can do similar actions here, doing like, for example, a double into an integer and other types. Just keep in mind that if you are converting across certain types with certain values, you could have data loss. So, for example, if I am having the number 4.2 and I'm going to convert that into the integer would have the value of 4, and so you could have some value of data that is lost with that. Now, what about explicit conversion? When the user manually changes data from one type to another, this is what's known as an explicit conversion or typecasting. Now, there are three major ways in which we can use explicit conversion in C++. We have the C-style typecasting, also known as cast notation. We have function notation, which is also known as the older C++ style casting. And we have type conversion operators. Let's look more at the first two styles because those are probably the two more common ones you're going to encounter. So with the C-style typecasting, this is the type of casting that's much more favored by the C programming language because remember, C++ is built off of C. This is again known as cast notation. And the format is always parentheses, whatever data type you want it to be, and parentheses, and then your expression. So if we look here, we have int num int is 26, double num double is our second one. And notice num double is not currently set to a value, but if I say num double is equal to num int, and I put that into a cast there of double, that's going to explicitly change that into whatever value I want it to be. It's not relying on the implicit, because sometimes, again, think about when we've done, like, if I want to do some kind of fraction operation. This is the time when we might want to have some of that double conversion in there so we can make sure we're getting the correct value that we're expecting. Now, function style casting is going to work identical to what we are seeing, except you'll notice that it's a little different. It's the data type followed by the parentheses being around the expression you want to convert. So you'll notice with this one, exact same thing, except now it says double parentheses num int. So again, exact same thing. Both these will get you the exact same output. It's just more of a stylizing thing. Now, for us who come from like the Java background, we're probably more familiar with that C-style casting, where we're putting what type we want it to be first before we pass it off into, whatever expression is. So again, the C-style casting is probably one that you're more familiar with rather than this function style, but both of these should function exactly the same way. Now, we, of course, should mention commenting real quick while we're diving around here with input and output, because comments, of course, are very important. C++ comments are, hints that the programmer can add to make their code easier to read and understand. We know that comments are used for things like documentation. They are used for things like, hey, I didn't finish this project today. I need to come and finish it tomorrow. I'm going to come in here and do that. Excellent. Just remember, comments are completely ignored by C++ compilers. You don't have to worry about any particular thing as long as you're following the comment style rules. So in C++, that means any line that starts with a double slash is going to be a single line comment. And if you're doing the /* and then */, that is our multi-line comment. So we do have that here, which is one of the advantages of C++ over something like C, because remember, C didn't really have a true multi-line comment. But here with C++, we can do that. And lastly, let's just really briefly talk on basic operations. Much like other languages, we can also perform basic arithmetic operations, addition, subtraction, multiplication, etc. pretty easily. So for example, if I int num1 equals 1, num2 equals 2, I can do cout num1 plus num2, and that would of course give me the sum of that. So let's go ahead and pop on over to handle an example with doing this. So here I have int num1 equals 1. I have num2, but I haven't defined what num2 is. So maybe I want num2 to be a number that is coming from the user. So let's go ahead and just do a cout message here. That's just going to ask for the user to enter in a prompt here. So let's just go ahead and say like, please enter an integer to be added. And then we can, of course, then use our cin to go ahead and define that to num2. And now num2 will be defined here because now we, of course, have that value. And what do we want to, else can we do here? Well, if we want to add in a comment, for example, we can add a comment that just simply says adds 1 to a user-defined integer. And if we want to show, let's say, a type conversion, let's just go ahead and do a simple one. So let's do, say, a fractional typecast. So if we had, let's say, a double, and I took, let's just change this though from 1, let's make this 3, just so we know we have a number that's going to work. Let's call it double fract. And we'll set this equal to, let's do num2 over num1, and then we'll do a cout of fraction. And let's just go ahead and give that a quick run, see where we're at here with this. All right, please enter integer to be added. All right, and so right now, of course, we have 3 in here. Let's go ahead and make this 5 and hit enter. And we got 81. All right. Now, you notice in here that 81 doesn't necessarily make sense. So it's because we never ended that line. So that's the first thing we need to do. So that's why we can always test our code here. So right here in our cout here, we want to end that line. So we'll do end L. And then now if we go ahead and rerun that output, let's just do 5, hit enter. Now you can see we get 8 and we get 1. Now, remember, this doesn't make sense here because we think about this, we have 2 integers here. So we need to do a typecast in here. So I'm just going to go ahead and add a typecast in here to num1. And so now if I rerun this code again one more time, we should, of course, get a cout command that's going to be much more what we're expecting. So again, we'll hit 5, and I see 1.6667. All right, excellent. And that gives us a good demonstration of how to use some of this C++ knowledge that we have been building up so we can make better and stronger programs.